vagus nerves, and mast cells. That's why we're here, and I'm glad we're all exploring this very important area of our bodies, our reactions, what to do, understanding what this whole thing is about. But first, a little bit about me. There's always those first 3 pages. It's just a little bit about me. I am here in the US and I have MCAS. I have a systemic mast cell disorder. There's a bunch of stuff about me. You can check it later. And emails to the websites. And here's a little roadmap for what we're going to talk about today. There is a little bit of a dive into the biology of things. So if you've got your science geek going, it's important. And looking at just a little explanation of the roadmap. To talk about vagus nerve, you're talking about cranial nerves, you're talking about the nervous system. So we're just going to take a look at that and how that just functions, and then how mast cells connect with that, and then some strategies to support health and maybe help bring down reactions and things like that are very vagus nerve aware, and having that awareness of our nervous system and that level of things in our bodies. So there's the quote, a little Mae West. I thought it was kind of appropriate. I speak 2 languages, body and English. And I think we all kind of do our version of that in some way, shape, or form. Dealing with mast cells, it's becoming fluent in this whole other language of our body that's we never planned on doing or being, but here we are. So the first part of it is taking a look at our nervous system. And our nervous system is in charge. It runs everything. It allows us to do everything: move, eat, feel, think, digest, breathe, have memories, remember, sleep, everything that we do. And it responds to things as well. It's this communication network and system that's nonstop 24/7 since the minute we were created. It's just like, it's this whole network and relay and webbing of communication. And we're kind of familiar with this. This is, we know that there's the central nervous system and there's the peripheral nervous system. And the central nervous system is basically your brain and your spinal cord. And the peripheral nervous system is everything else. The central nervous system is made up of your brain and the spinal cord, and they are mainly responsible for processing back and forth. And when you hear processing information and controlling functions, it's talking, there's a part of the nervous system that's for taking in the information, and then it sends it to another part of the nervous system that's responsible for making our body do things in response to that information. So that's what they're talking about. Your brain, thinking, learning, your movements, feelings, and your spinal cord carries those messages. That's how it goes between your brain and the rest of your body. So there's the central nervous system, CNS, and PNS is the peripheral nervous system, which is everything else. And it's all the nerves that connect the central nervous systems, the rest of our body, so that our body and all of our organs functions and works and everything makes sense. And we're able to perceive and feel and taste and smell and everything, and be angry, be anxious, be happy. The peripheral nervous system is divided further into 2 systems. There's the somatic nervous system and the autonomic nervous system. And it's also further divided into the sympathetic and the parasympathetic. You don't have to like memorize any of this. There's not a test, and there will be more slides explaining it, but it's just important that there are systems and levels of communication, and everybody's got a role, a job, and a function. And we listen and we send the information. Now we get the muscles going. It's just very structured like that throughout our whole body. The somatic nervous system controls all of the body's voluntary things that it does. Walking, the things that you think about, you're going to move your hand, move your arm, you're going to turn your head, you're going to take a bite of something. Those are all voluntary. So that's all the somatic nervous system. Decision making, because it's all connected to our brain. So it's part of our thinking. And the 3rd little bulleted item there, it says it's responsible for our conscious perception of the environment and for our voluntary responses to that perception. So that's that awareness. It's where we are in space, physically, what the temperatures are, all of that level of responding to our environment is part of the somatic nervous system. The autonomic nervous system controls all of the body's involuntary functions, like your heart beating, breathing, your blood pressure, the things that happen that we don't think about, like the fight-flight response and the rest-digest response. And it also regulates organs and glands, all the things that we don't have to think about to make work. And also maintaining homeostasis, which is that balance, a healthy balance of everything and everything working well in your body. So that's the nervous system is huge. It's this whole communication relay. And the autonomic nervous system then goes to the sympathetic and parasympathetic. So the sympathetic is the fight flight. It prepares the body for doing something. It's taking in the information. That's the sympathetic. It gets the information and it sends the money, and the things that happen. It's that alert are you in danger? Your heart rate and blood pressure go up, your digestion slows down. There's all these physical things that happen in your body. All of your cells recognize these responses. And mast cells tend to think of it as like, oh, there's a threat. But so there's the alert. That's the sympathetic nervous system. The parasympathetic nervous is the opposite. It shuts it down. It slows your heart rate. It pumps up your digestion again, and it conserves energy. It's the relaxing part of it. So there's a lot of things that happen in our body that this part of our system jacks it up, and this other system calms it down, and they work together. They're communicating the information that the nerves are sending, all the sensory nerves throughout our whole body, through our brain, through our spine. It's all of this going on. And I find it amazing that they're working in tandem. And it's like, this one will ramp it up, this one will slow it down. And that we know so specifically at this moment in time in 2025, what these responses are about, and can these little tiny cells they're doing all of these huge things that we respond to in our bodies in huge ways. And then there are cranial nerves. And cranial nerves, there are 12 pairs of them. And there are pairs because there's one that goes to the left half of your brain and the other one goes to the right half of your brain. And they do not go through your spinal cord. They are in direct communication with your brain and back and forth. The vagus nerve is one of them. And typically if you read about it or medical things in textbooks, they're given the Roman numerals for 1, 2 through 12. That's the name, or it might say CN and Roman numeral 4, which is talking about cranial nerve number 4. But I kind of like this little cartoon because where the numbers are, that's the area that it's regulating. Tends to be, we think of cranial nerves from like the torso up until it comes to the vagus nerve, because the vagus nerve is huge. It's the biggest influencer there. And so this is what I just kind of gave you in a little nutshell, that there's 12 pairs of them. And that's why sometimes you see vagus nerve, or sometimes it's vagus nerves, because there's 2 of them. So, but they're doing the same thing just to the right and the left side of our brain. So they help us see, smell, taste, hear, move our facial muscles, make facial expressions, blink our eyes, move our tongue, feel touch to sense pain, to be able to sense temperatures. And our body parts, eyes, ears, nose, mouth, they can't work if our cranial nerves aren't working well. And motor nerves play a role in controlling specific muscles. And some cranial nerves have both sensory and motor function. So that's going back to, it can be one cranial nerve that takes in the information and will respond to it by telling muscles and parts of our body what to do. Lots of times it's 2 separate groups of muscles. These ones do getting the information, and then they send it to this group, and that group does getting the body actually moving. But a lot of the cranial nerves do that all by themselves. So this just lists the 12 of them and what they kind of what they do, their purpose, what they regulate. The one that we're here really focusing on is the vagus nerve, number 10. But it's also really important to know that they don't work independently. All of these nerves work together to make things happen. So the vagus nerve regulates a lot of automatic body processes: digestion, blood pressure, heart rate, breathing, mood, saliva production. There's a lot. And it runs from your brain to your large intestine, but it meanders. And it has little sub nerves that, so it's covering it's touching and impacting your whole body. And it's the main nerve of the parasympathetic nervous system. So for the things that are responding, the autonomic things, the ones that aren't planned behaviors, it's huge. And the cranial nerves, they do all work together. They coordinate specific body functions like seeing and what we taste and smelling things and hearing. And they work together with our eyes, our facial expressions. These are all, we understand when we on the outside see somebody smiling. And we know what that position of facial muscles and that expression means. But there's also an interpretation that's going on at this nerve ending cellular level, that when we move our muscles in a particular way, they are understanding it as like that smile that you're telling directly to your brain, I'm okay. It's the opposite of fight flight. But we're not really thinking about it in these ways as we live our life day to day. We find things, we laugh, or when we're serious or stressed, we have another facial expression, but this is all communicating specific information. And then it targets particular nerves that behave in particular ways because of the information that they're receiving. So key points about cranial nerves working together. The cranial nerves, they each have their own special function, and they originate directly from the brainstem. So that means they're capable, and they do take care of a lot of complex processing and coordinating information, input and output. Input is here's the information, output is what your body's going to do with that information. The sensory motor integration, some cranial nerves carry both sensory and motor information. That means they can both receive sensory input, that information, and send the motor commands to respond to the rest of your body. Usually it takes two different nerve communications. And while each pair of cranial nerves has a specific role, they can sometimes interact with each other to achieve coordinated functions, like collaborating with your vision and how you move yourself to, sometimes it's the squinting to see more clearly. All of these sub things that we do without thinking, these are all coordinated things between these cranial nerves. Here's a couple of more examples of the collaboration. Chewing. When you bite down, your trigeminal nerve sends the sensory information about the pressure on your teeth to your brain. And that sends motor signals by the same nerve to the muscles that you need to chew to start that chewing movement. And it's kind of cool that other activities are two different sensory nerves. It's not just the same one giving the information back and forth. And also taste perception. The facial nerve carries taste information from the front of the tongue, while the glossopharyngeal nerve handles taste from the back of the tongue. So if you think we're just eating, we taste something and it tastes good, and it's chocolate or it's ice cream, because I really would like for it to be chocolate ice cream today. But there's all these different nerve endings to get the flavor from the tip of your tongue to the back of your tongue involved in all of this, and everything is sending signals to the brain so that we get, yes, chocolate. But and it's so instantaneous that we don't realize there's any time lapse, or that there is this communication journey happening of information. So the vagus nerve is very, very important. A ton of information goes back and forth through the vagus nerve, or via the vagus nerve, between the brain, the heart, your digestive system, your immune responses, your moods, your skin and muscles, your speech, your taste. These are all impacted and influenced and to some degree regulated by the vagus nerve. And that the left nerve goes down the left side of your body and the right one goes down the right side of your body. And I thought this was interesting that the word vagus is Latin for wandering, because there'll be another slide coming up. You see, it's just like, it just meanders and wanders through your whole body. So it starts from the lower brainstem, your neck, your chest, your heart, your lungs, your abdomen, your digestive tract. It's just meanders through. So this is the image that it connects in some way or another, connects to all your body's organs pretty much. And it helps control the autonomic functions, just the things you can't control. It helps to keep it so that you're not aware that your heart is beating, and it just does its thing. And it also conducts physiological emotional responses such as fear and pleasure. So anxiety is part of it. It's part of the communication highway. And it has a lot of branches. So this just details it out to your liver, to your pancreas, to your spleen. And when I was putting this together, just because this is who I am, everything kind of filters as I was looking at, and it's all going through the lens of mast cells throughout the whole thing. And and when you think about people who have respiratory issues that are mast cell reactions, and all the digestive issues that are mast cell reactions, and then pains and spleen, all of these, and your pancreas and inflammation, and this is the vagus nerve is part of this communication network, and how our body responds to the information and what the information really is about. So what the vagus nerve does is huge. Whether you have mast cell activation issues or not, it's huge, but it's especially significant, I feel, because mast cells are a part of this communication system and relay. So this is kind of summing it up a little bit of how the vagus nerve and other cranial nerves work together. I don't have to read the whole thing. We were just talking about it, and you can check it out, when you look at this later. But I thought the last bulleted item there, where it says damage to the vagus nerve can lead to difficulties with swallowing, speaking, impaired taste perception, often presenting alongside dysfunction of other cranial nerves involved in the head and neck. Especially when I read that, it caught my eye, thinking about how now we're in a world of long COVID and all this other array of symptoms, and the impaired taste perception is a big symptom of that. So it just pops in my head. So enter mast cells. So there's all this communication going on with all the nerves and the nervous system. And mast cells are everywhere. They're found in the connective tissue throughout the whole body. There's layers and layers just of connective tissue, and multi-layers in every single muscle that we have. There's not an inch of our body that doesn't have some type of connective tissue. So mast cells are everywhere. And that's why when we're having mast cell, the mediators release and mast cell activation reactions, they are systemic, and they depending on what mediators, what a person has been exposed to, the chemical toxins, is going to influence where you may feel it's the strongest. But like some people, for me, breathing is huge. It takes nothing and I can't breathe. But that doesn't mean that's the only thing that's going on. It's a storm of reactions that we have with mast cell disorders. And that's because mast cells are everywhere. And they're part of our body's immune response and our inflammatory response. And if there's anything that's perceived by all these nerve endings, oh, this must be a danger, they're the first ones there. And we kind of are seeing that there's something with MCAS and other mast cell activation related disorders. There's something askew with the messaging system, something that they're behaving badly, unknown reason, but the communication isn't accurate. Maybe that's what it feels like, and research is looking that way. It's pointing to these miscommunications and misfirings. So mast cells, they communicate with all the different cells in our body. They communicate chemical signaling, which is the release of mediators. Those mediators are giving our bodies specific information. With a body that doesn't have a disorder, it's to fight a virus, bacteria. It's to keep our health. When things are reacting for no real reason, and they're pumping it out, it becomes very harmful because there's not combating anything except our day-to-day breathing and how we're feeling. But cells can also, in addition to through the mediators, just by physically being close to other cells, they can tell each other information. So just a mast cell just hovering next to a nerve-ending cell, there's information and they're going to run with it. And mast cells are a type of that division of labor between these cranial nerves. These ones send the information, this one gets the body activated. At this cellular level, mast cells do both. It's also divided up, it's division of labor, but mast cells do both. They will get the information, they will run with it, they will get all the other cells in your body activated, they will get other mast cells activated. And it's this huge, we got to save the body, but really with the mast cell disorder, you're not saving the body, you're making things a little worse with the intensity of things. But what's important with this is that this communication is going on. Mast cells are present and they communicate in the central nervous system, the brain and the spinal cord, and in the peripheral nervous system, which is every single nerve in your body, and they're talking with the organs, your muscles, and they're in conversation with the cranial nerves. So to hear that, to just say, I have a reaction, that's, I was reacting, that's such a small word that implies this universe of stuff when you have a mast cell issue going on, that sometimes even medical professionals don't really understand that, but we'll keep teaching them. So here's some things with the vagus nerve and specifically mast cells. So the vagus nerve can modulate mast cell activity. It influences mast cells. It can make them degranulate. It does mast cells and going through the blood-brain barrier, that's the BBB, and the intestinal barrier. So it can help, what they found with research, for after someone has had a stroke, this communication can help. But it's also, this communication is part of our gut microbes. And we know from irritable bowel syndrome and all of these things that there's a lot of miscommunication that happens as well. That's part of the issue. The vagus nerve influences mast cell behavior through the parasympathetic nervous system, which is for controlling the inflammation and maintaining mast cell activity to keep things balanced. Every human body wants things to be in balance. That's the homeostasis piece. It's like our bodies have this driving need to have things be in balance. Sometimes it does get messed up. And that includes moments of activity, moments of rest, when we sleep, when we eat. In MCAS, the vagus nerve influence is especially important because dysfunction in the vagus nerve can lead to increased histamine and other mediators and inflammatory mediators, which will make mast cell reaction symptoms worse. And so then it's looking at, whoa, well then vagus nerve health is hugely important, and how we manage stress once again in our lives is hugely important. So research shows that the vagus nerve, getting it stimulated, sometimes you see in capital letters VNS for vagus nerve stimulation. In doing, that's a specific approach and a strategy, and that can inhibit cardiac mast cell activation and improve myocardial atrophy after a stroke. So again, that's because there are mast cells in your heart and in the pericardium, is that's connective tissue that's surrounding your heart. The mast cells are there, and they're having an impact, for better or worse. And the vagus nerve significantly influences mast cell activity through mechanisms that include direct stimulation and modulation of inflammatory responses. So it's another layer of how important it is to not just, it's managing stress, but in managing stress, we're managing that inflammatory response, because that's just a mast cell response to a perceived danger. And if we're stressed, our body is perceiving danger, whether it's work, having to have a difficult conversation, just having to be awake because it's like a bad day reacting. It becomes very, very important how we approach the way that we internalize things what we let in, the energies that we let in, and how we manage our stress in every day. And one big approach is food as medicine. And I like this. Let thy food be thy medicine. But and because it's huge, what we take in and what our body does with it, the histamine, we're all getting so understanding with that, the histamine bucket and just what's going on with that. But there's also vagus nerve food health. And sometimes, because it can be very challenging what to eat, how we eat, whether or not we're going to react to anything and or everything we put in our mouths in any given time, lots of diets can be severely restricted. So within that, it's still trying, as one is able, to make food choices that support mast cell strength, to help mast cells not degranulate, and now maybe adding to it foods that support vagus nerve health. So again, that this is kind of saying it, the vagus nerve is like a highway between the gut and the brain, and the neurotransmitters like dopamine and serotonin and norepinephrine that are produced in the gut, they travel along the vagus nerve to the brain. And these affect your appetite, pain, mood, memory, all of it, the mast cell reactions, they're in here being impacted, influenced, triggered, enhanced. The vagus nerve also senses and tells the brain about inflammation that's happening anywhere in the body. And if there's inflammation, there's stress. And if there's stress, there's cortisol. And we're learning this more and more. And how to where can we step in consciously to stop that chain of reaction of cortisol, stress, and mast cells and in our bodies. There are receptors on every single mast cell for cortisol. And when the cortisol hits those receptors, the mast cells degranulate and all those mediators come pumping out. Histamine is a big one, but there are a lot more, and they bring on all the things that we're feeling. The vagus nerve not only senses inflammation, but it can also inhibit inflammation. So it sees that it's there, and it's that double-edged sword. To sense that something is going on, then how can we step in, and in what ways can we send a message to our bodies to chill, to calm down, to not ramp up in the response when it's inflammation and mast cell degranulation. The vagus nerve's anti-inflammatory properties are part of the reason why it has become a therapeutic target for healing conditions, such as irritable bowel syndrome, diabetes, rheumatoid arthritis, and they use vagus nerve stimulation. And I find it interesting that the knowledge is there in those areas, but it's not, I don't find the dots being connected, that there's this mast cell thing that's going on that's a part of everything. So that's okay, because here's this information that's there, and we know, and I see it as part of our mission to just sort of who we are in contact in our lives, in our day-to-day, just explaining this is why it needs to be, and this is why I need things this way for my health. And that's an important conversation that we need to have. But that they're getting there in these little ways. You're finding more and more, okay, they're getting this piece of it, let's take it to this other place. And so here are some foods. Foods that support vagus nerve health include choices that are high in fiber, prebiotics, choline, omega-3 fatty acids, vitamin B. So fiber, whole grains, fruits and vegetables, broccoli, peas, beans, skin on the potatoes, fruits, prebiotics, garlic, onions, bananas, asparagus, chicory root, leeks, oats, barley. And these are food items. Some people can eat one of these, none of these. It really is so individualized. But if you find yourself on a day or a week or a season or whenever it is that you might feel, let me try a little something, you might want to pick something that's off of the list. That's like, okay, I know this is helping with vagus nerve, and I know this is a mast cell stabilizer. Let me see if I can make those choices first. Anna, just a side note, I found myself last week, after like 15 years of not being able to, asparagus is one of my favorite vegetables. I haven't been able to find any that I don't react to. Like, okay, asparagus, EpiPen, no difference. But I found some asparagus like 2 weeks ago, and I've been able to eat them. only the bird's eye frozen ones, and the ones I put in the mic, they're the only ones. But and I was started eating them before I got to this part of putting together this PowerPoint. And I was like, and sometimes I eat things and it's like, am I just making it up that I feel like I'm feeling better because I just ate that? Then to read, okay, well, here, asparagus is doing something that's helping with the mast cell stuff, and I was feeling it. So just because that was my experience doesn't mean it's going to be anybody else's, but it's worth it to do the food journey for yourself and find things you can, and not to quit just because you can't have it now. Try it in a month, try it in 6 months, try it in a year. Don't quit trying, because the more you can take in that support mast cells not degranulating and not being the rush of inflammation and all that going on, the more you can do that, the better you feel. It's more tools for your toolbox in managing symptoms. Salmon, omega-3 fatty acids, flax seeds, walnuts, vitamin B, soybeans, brown rice, ginger root is wonderful. I knew it was like for inflammation, didn't know it was improved vagus nerve function. It's just one more reason to try it. I used to be able to cut up ginger root, put in boiling water and pretend it was tea because I miss drinking tea. But and tryptophan, which is spinach, seeds, nuts, bananas, poultry. Yeah. And I think of it like when you have, like on a holiday, if you have Thanksgiving or turkey and you just eat it and then you're really tired, that's what it is. And it's also in tuna. So I was like, oh, so it's also something that is good for one's vagus nerve. And I was surprised with that one. This is another one, sodium intake. And I actually included the research study if you wanted to look at it, that if low sodium was associated with decreased vagal tone, and a high sodium intake is increased vagal tone. So if you're not taking in enough, and we live in this low sodium universe all the time. No, too much salt is bad. What's too much salt, it's not great for your heart and things like that. But if you don't have enough sodium, it's going to weaken, it'll decrease your vagus nerve tone and function. So that might be something to check one's sodium levels to make sure, and sodium intake to make sure it's not too low if you're able to use salt, because that's something that can impact the vagus nerves. And also the vitamin B12 specifically. And so there's some, the sheaths that are around all your nerve endings that protect them. They develop when kids are little. That's why, like, if people are going to be on a low or lower fat diet, you don't want children to be given low fat, because they need the fats in their diets to develop the myelin sheaths that protect all their nerve endings. So it's interesting that we still need to support those myelin sheaths once they're there to help with our vagus nerve health. So more reasons to find things that you maybe can add to your diet. I have a very limited diet, so I totally understand how challenging that can be, but you just gotta not quit. So these are things to add to your personal toolbox, as we were talking about. And this is a little bit of a bulleted list, but I have more wordage because I when I put these together, I really think about not having it be 8,000 slides, but really, how can this be presented in a way that people can take the information and really use it and start thinking about their own lives and their own choices, and how maybe things can be tweaked to have through a better understanding, have more effect in regulating mast cell reactions and that whole universe. So some of the strategies, there's the vagus nerve focused breathing, because when there's a situation that's stressful, that's triggered the fight flight response, and we're running, I think at one time I called it, in the jungle, there's that saber-toothed tiger coming after us, and we run till we're safe. And when you're safe, but when you're being chased, your whole body, your pupils dilate, all those reactions, your digestion slows down, your heart rate pumps up, all of that's happening. So your body's like, danger, run. And then when you get to the cave and you're safe and you're like, okay, you're exhaling, you're putting emphasis on the exhale, because you're inhaling and exhaling, but emphasis is on the exhale, and you're giving it a vocalization while you're going, and you're also glad that you're not going to be eaten by the saber-toothed tiger. That emphasis on the exhale with the vocalization is direct communication with your vagus nerve that you're okay. And it's talking directly to your brain. It's the opposite of let's get that fight flight going. It's what shuts it down. So, except that's kind of hard to do at the gym, to go, because people will think you're very strange. But any way that you can incorporate that kind of awareness intentionally, and it's not a one-off, what teaches new things to our brains and new reactions, reprograms our brains and our cells, is repetition. You got to do it over and over and over. And the more you do it, you'll start feeling it. It doesn't mean, and this is just one of multiple tools for your toolbox, and we tend to need to pull them all out, a lot of them out all at the same time every day. It's not just, oh, if it was just do this and everything's fine. Just do this one thing. That would be terrific. But it's not that. But that one, the other one, that the next one on the bulleted list there is facial nerve aware smiling. If you smile, that shape and movement of muscles of your face through the facial cranial nerve is telling your brain, we're good, we're happy. So if you're able to smile and do that breathing, and if you can't smile, if you take a pen or a pencil and hold it like this, you've moved your muscles in the exact same shape, basically, and that's telling your brain the same thing. So if you're, and as an example, if you have eaten something and you feel yourself, oh my gosh, I'm starting to react to this, you can start the breathing with a smile on your face. Does it mean you're going to immediately stop reacting? No, but it's kind of like an attack on and overlaying the conversation with your mast cells. They're going, danger, danger, we're going to ramp up, and you're giving them in all the ways you can think of the message, no, we're good, don't ramp up. And I know it sounds, we don't usually sit around thinking, how can I talk to my body on a cellular level? But that's what you're doing. And these are all important tools for the toolbox, as is what you eat. And the circadian rhythm awareness to know, mast cells, they have found, have their own circadian clock. And it's very much in tune to light and dark. It doesn't mean that you have to go to bed at a certain time but our body wants regularity, and it looks for it. And not everybody, depending on how you feel, it's going to greatly impact any kind of regularity at all. But within that, sleeping, exercise, and eating, if you can try and do these somehow in a very general way with a certain regularity, not, it isn't going to be always like 2 o'clock every afternoon, I'm going to eat. But if you're able to, you wake up whenever you wake up, you eat something, then you eat something later, then you eat something, however you do it, that you try and kind of have it be similar from day to day. Your body will be happy. It knows what to expect. And because when you don't know what to expect, your mast cells and the cells in your body get tense. It's like, is this a pre-danger state? The other part of it is exercise. And that can be very challenging because for some people, the physical exertion is triggering. So does that mean you don't move your body? Ideally, the suggestion is no, don't try to find a way. It doesn't have to be this, full out sweat till you drop exercise. It can just be being aware, I need to maybe move around a little bit today. It can be walking around your house a little bit, never to the point that it's going to trigger a reaction. And always talk with your care providers to see, what works best for you. But exercise is the third piece of it that is hugely important with the circadian rhythm, and also in retraining and reprogramming our cells, both our brain cells and our mast cells. Because if they're going to, it's hard to be faced with a situation that could in a few moments be potentially severe and life-threatening reactions, it's hard to not go to that place of fear and worry and concern. Oh my gosh, am I going to end up in the emergency room? It's how do you not go there? But the fact of going there adds to the stress. So if in the moment we can have lists of our toolbox, let me try this, that includes medication, That can include eating something, because sometimes I know I was talking with someone just recently and they were trying to be able to tolerate a new medication that they and their doctor felt that they needed, and up titrating it very slowly to start. And that in the beginning, it may not be about hitting the therapeutic dosage to start, but just to get your mast cells to not react, that this isn't a threat. This is a strange chemical I'm putting in my body, but it's not a danger. And starting there, using food, because we're here, so there are some foods that we can eat. So taking a little bit, so lots of times it's dissolving a medicine in water, taking a little bit of that, and then eating a food that we know we can tolerate, because they taught me in nursing school that it was specifically about when giving an injection, but this is just true with our nerves and our nerve endings, that they can only send our nerve fibers can only send one impulse to our brain at a time. So when you're giving someone an injection, nurses will grab, like if it's in your arm, they'll grab it and you get pressure, they'll squeeze your arm, because that's before they insert the needle, because that's the message that your nerve endings are sending to your brain: pressure, pressure, pressure. So they're not going to be, if you're squeezing at the same time, you did that first, they're not going to be saying ouch, pain. They're giving pressure. The same is kind of true. Okay, you've taken something new, a little bit of medicine, and you're starting to react because it's new. But if you have something there that you eat, that's, it's kind of overriding the message. So that seems to be helpful for some people. This is, again, a strategy that may or may not work for everybody. It's just, we are each our own guinea pigs. We got to find out. And the next piece of it is the food as medicine, and how important it is to make informed choices about histamine, about what foods are mast cell stabilizers, about now what foods help with support vagus nerve health, because that's going to help support not having such bad reactions. We hope, you know, and when you're going to add on, when you're thinking about, oh, I want to eat something, and it's like having that awareness in your choices is supporting those moments and extending them where you're not reacting. Medications are just one more tool for the toolbox. They're not the be all and end all. Some people don't want medicine, and that's fine, because all these other things are still supports for their body and for all of our bodies. Sleep is another one that's very important, because there are processes that happen in our brain that detoxify our brain that happen only when we sleep. So those are the big mast cell strategies, and also being patient with ourselves and with our bodies, and kind to ourselves. We're always so good at being compassionate and caring for everybody who matters in our lives, and we forget to be that way with ourselves. And it's hard. It's hard, because it would be so much easier if everybody reacted the same way and everybody responded the same way to the same supports. It's so wonderful that Mast Cell Action has so many supports that they offer for people: exercise, creative arts things. We have these conversations. Then there's the Thursday community Zooms, which is they're all important and significant ways of connecting with each other, sharing our learning and our knowledge, and support for the journey can't be, undervalued at all. So I had like this little quote here. I like Thich Nhat Hanh. He keeps coming up in my presentations, but he peace while breathing, peace while walking, peace is the breathing, peace is the walking. He has a book. It's all about walking meditations. It's called The Long Road Turns to Joy. And it's one that you can just, it's a book that's long ways. It's not, it's this way. And you can just open it up, and it has a picture on a page and like a paragraph or two. And you can just randomly open it, and there's something to think about that's I find is helpful and positive. And I like to walk. There are some days where that's about all I can do. I can just walk around. You don't have to be like outside. and he talks about that, to just, one of them was just to think about the way you put your foot on the ground, and that relationship we have to what supports us. And you can take that to such a huge space, because when you think about what is it that supports us, is where do we find our strengths, and where do we ground ourselves, and then peace is the breathing, and breathing is so much more than yes, it's the in and out and the breath we take, and how that feels in our bodies, but it's also about what keeps us alive and what keeps us fueling our own sense of strength and worth. And peace is the walking, and that journey of each today becomes so important when you think about it. It's just like breathing and walking, but you're supporting all the best of the things you want to maintain and to grow inside ourselves, in spite of the challenge of mast cells. And in focusing like that, you're choosing, we all get to choose what we're going to emphasize inside of ourselves, and how we're going to interpret our experiences, and the meaning that we're going to give to them. And if we're in this, goes right to managing into the stress part of, because we can't escape stress. Wouldn't that be terrific? Wake up and it's a stress-free universe. But within that, what do we every minute of every day choose to ground ourselves in? I know it may be hard to see some days that it is a choice, but within that, it's like, in this moment in time, I'm going to focus on this. And in that moment, you're choosing what you're grounding yourself in. And so that's what that made me think about. And I was like, these are good thoughts. I want to share these thoughts with whoever I may encounter for this sharing. And then the last pages are just the references there. And these are Matisse. These paintings are Matisse. This year, Matisse became public domain. So I was like, yes. I shared those because I like them. And that's the end.